All right, welcome back. We are on 10.3 still. Now we're on the backside, P176. And just a reminder, scalene triangles have no equal sides. Isosceles triangles, 2 equal sides, and equilateral triangles, all the sides are equal. All right, let's look at number 1. The kite is made up of 2 triangles. We have a triangle here and this triangle here. Are they isosceles, equilateral, or scalene triangles? Well, we know this length is going to be the longest because I have an obtuse angle right here. So I know this side's going to be the longest. So I definitely know it can't be equilateral already because it has an obtuse angle. Now this line is going to be different length than this line. So it's different, but it's going to be the same length as this side. They're mirror images of each other. And then this side, I know, is going to be different than this side. We can see that pretty easily with our eyes, that this is a longer line than this side, but this is the longest line. And so I'm just showing that they're different by putting these little dashes, 1 dash, 2 dash, 3 dashes. All the lines have different number of dashes. So we know they're all different, but then this line and this line both have 2 dashes, and that's showing anyone that's looking at this that this line is equal to this line. This line has 3 dashes through it, so it's showing that it's equal to this line, which also has 3 dashes through it. Well, again, we can see all these sides are different, so that is scalene. Number 2, the hanger has the shape of a triangle. Is the triangle isosceles, equilateral, or scalene? Well, here's my obtuse angle, so I know this line is going to be the longest. And then with a hanger, I know these 2 sides are going to be the same length. So it has 2 sides, 2 equal sides, so this is isosceles. Okay, going on to number 3, Samantha has 3 times as many baseball cards as Mark. Mark has 12 baseball cards. Write an equation that shows how many cards Samantha has. Okay, so Mark has 12 baseball cards. Samantha has 3 times that many. Well, 3 times that would be 12 times 3 equals, and then 36. So Samantha has 36 baseball cards. Okay, number 4, a store worker wants to pack 137 cans into boxes. Each box can hold 9 cans. The worker fills as many boxes as possible. How many cans does the worker have left over? So, again, we could draw a picture, or if you recognize this, we're going to be dividing, okay? So, we are dividing 137 cans by the number of cans that can go in each box, which would be 9. And then our quotient will show us how many full boxes, and our remainder will show us how many cans are left over. Okay, another way of doing this, again, though, we could draw a picture and say, okay, there's 9 cans in that box, another box, 9 cans, another box, 9 cans, and continue going and adding as we go to see how many, to get as close to 137 as we can without going over. Now you can see that would obviously take a long time to do, but it's one possibility. Another option is we can do repeated subtraction, but rather than start with just subtracting 9, I'm going to use a little bit of common sense and jump all the way up to 90. Because I know 10 times 9 is 90, so I know we can have 10 of those boxes with 9 cans in each box. If I have 10 of those boxes with 9 cans in each box, I have 90 cans so far. So I'm going to show that those 90 cans would be 10 boxes filled. 90 cans would fill 10 boxes, and then I subtract that, and I have 47 left. So now I can see, okay, well, I know my 9's 45. 9 times 5 is 45. So 45 cans would fill 5 boxes, right? Because 9 cans in each box, 5 boxes, that'd be 45 total cans. Subtract that, get 2. And a box fits 9, but I only have 2 left. So how many cans does the worker have left? 2 cans. So that was a couple different strategies you can use. So it'd be 15 total boxes with 2 cans left over. But again, if you want to do the straight long division, we can do that as well. Let me show you that real quick, and then we'll move on. So if you recognized that you were doing division, then you could just do the division. So 9 can't go into 1. 9 can go into 13 one time. 1 times 9 is 9. Subtract gives you 4. Bring down. There's the 7. 9 goes into 47 5 times. 5 times 9 is 45. Subtract gives us 2. 9 can't go into 2, so that is our remainder. And this problem wants to know how many cans does the worker have left. The leftover amount would be the remainder. All right, so a few different strategies depending on how well you understand the word problem and the math. But again, you can always draw out those boxes. There's 9 cans in that box, 9 cans in that box, until you get as close to 137 cans as you can. Okay, Gina has 24 raisins. It's modeled for us, it looks like. Let's see, we got 3 by 4. So 3 times 4 is 12. Another 3 by 4 is another 12. So you got 24. She wants to give the same number of raisins to each of 8 friends. Draw rings around groups of raisins to show how she should divide them. How many raisins should she give each friend? Question mark. Well, if you wanted to, you could first do the division, just because you know it's division. They're dividing the 24 raisins among the 8 friends. So 8 goes into 24 3 times with no remainder. So that tells me if it wants me to draw rings, I'm drawing rings around groups of 3 because each friend is getting 3. So we can see here we have 1, 2, 3, 4, 5, 6, 7, 8 of those different rows and showing 3. 1, 2, 3, and then my clicker won't let me draw them. There we go. 3, 3, 3, 3, 3. So here you see we have 8 groups with 3 in each group. So each friend, this is showing the amount each friend will get. The 8 represents how many friends so each one of these circles is a friend. And then the raisins inside is how many raisins that friend got. So how many raisins should she give each friend? 3 raisins. Alrighty. Moving along to number 6, Nate's quiche is cut into 7 equal parts. Well, I'm going to start pulling information out. If it's 7 equal parts, that tells me all the parts together would be the denominator, so the denominator would be 7. Only 3/7 of the quiche is left, so he started with 7/7 if he had a whole quiche, and something happened, and now he has 3/7 left. He wants to give 3 friends an equal part. Write 3/7 as the sum of unit fractions. Oh, okay. Well, we're not worried about what happened here. We just want to take this fraction 3/7 and change it into a sum. Sum means addition of unit fractions. So I know it's going to be fractions. I know I'm going to be adding, and a unit fraction means it has 1 as the numerator. So I'm dealing with 1/7. How many 1/7 do I need to get 3/7? I need 3 1/7 to get 3/7. So there is my answer. I've written 3/7 as a sum addition problem of unit fractions. All right, thanks again for watching, and I'll see you on the next video.